In procedural programming languages, programmer have to explain thoroughly his logic step by step. So it is not enough just to say what he is trying to achieve, but he has to explain everything. And for that, he will first declare some variables, he will give initial values to those variables, he will change those values by using some control flow structures like if, case, or while, and he will organize his code into blocks. In SQL, we usually just have one big statement, and that statement is a declaration of our goal, but database will know how to read that declaration, and database will know what should be done. So SQL is great for filtering, joining, and grouping, but it is not great when we have to do things step by step. In procedural programming languages, the major building blocks are procedures and functions. And we can hide our logic inside of those procedures and functions. So when we need that logic, we just have to call procedures and functions by their name. Procedures and functions can pass arguments between them, and all of this will allow for modular design and for better organization of a code. And because we can parameterize procedures and functions, that means that procedural language will always be more flexible and reusable than SQL. It is possible to use procedural programming language instead of a database. Most databases will support so-called procedural SQL. Procedural SQL is a way to extend SQL with procedural capabilities, and procedural SQL is based on SQL and is really close to that how databases work. Now, while SQL is universally standardized and we can use it on any server, procedural SQL can really differ between different servers. So we have different dialects of procedural SQL, such as PLSQL in Oracle or TSQL in SQL Server. Now, we will use procedural SQL when we want to perform complex transformations, when we need logic flow control, when we need more flexibility, so our logic must be parameterized, when we are performing validation and error checking, and when we want to embed application logic into a database to avoid expensive network round trips. But we will also use SQL because SQL is standardized and it is portable between different servers. It is faster, it will use less memory and computational power. It is less complex, so user doesn't have to be really familiar with structures of data in one database and with algorithms to get that data. And it is easier to read because it is just declaration of our goals. The reasons why SQL is faster than procedural SQL are: SQL gives the optimizer more information on which to base optimization. SQL needs less logging or for rollbacks and transactions. Less locks on tables are taken when we use SQL. And because set-based logic is focus of databases, they are heavily optimized for that set-based logic. Inside of Monet server, we have many built-in functions. But sometimes we want to create our own custom function, and for that we can use procedural SQL. I will jump here to terminal and I will create one really simple function that is using procedural SQL. This function has a name, it has parentheses. Here we would put arguments, but this function doesn't have any arguments. This is return data type, and this is return value. So our function will always return number 2. If I run this, our function will be saved inside of Monet, and now we can use it. So I will use it inside of this select statement. This select statement will call this function, and we would get our result. It is also possible to delete this function. For that, we would use this statement drop function and then the name of a function, and now our function is deleted. It is also possible to use select statement inside of a function. So inside of this custom function, we have this select to statement. This select to statement will return a value, and then that value will become the result of our function. So our function will return that number. So if we run this, this will be successful, and like previously, we can try to use this function and we would get the result 2. But because we're always expecting integer as a result of our function, this select statement must return integer and must return scalar. If we have a select statement that is not returning scalar, like this one is returning a column, this select statement will not work inside of our function. Let's try that. I will create again our function, and I will use this select statement that is returning column. So I will run this, and this will be successful. So we'll accept this function, but when we try to use it, so if we use that function instead of select statement, this will not be acceptable because we are expecting scalar. I will now clear my screen. I will now create one sample table. This is a simple table with 2 columns. I will insert one row of data inside of this table, and we can also read from this table to see how it looks like. After this, I will create another function, but this function will accept an argument. And as we can see, this argument is of integer data type, and this function will return that argument increased by 2. So I will run this. Our function is saved. We can see now how our function works. So I will run this select statement, and this select statement will take this argument and it will increase it by 2. So we would get 77. We can also use this function on our sample table. So our sample table is numText. We will apply our function on number column, and inside of number column we have number 120. So if I run this, our result will be a number that is 120 plus 2. So that is 122. I will now clear my screen. Data manipulation statements like select, insert, or update will work fine inside of custom functions. I will now create one new function, and this function will apply update on sample table. And afterwards we will read that updated value. So I will run this, and then we can execute our function. I will use this function instead of select statement, and we would get that updated value. On the other side, we have data definition statements like create, alter, or drop. So will they work inside of a function? Well, I will try this other function here. This other function will first create a table, then it will insert a value inside of that table, and then it will read from that table. So I will run this, and then we will execute this function inside of select statement, and we will get the correct result 7. So it seems the data definition statements will work inside of a function, but let's test that more. I will now read from this sample table, and I will see here that that updated value is permanent. But if I try to read from the test table, and the test table is the table that we have just created inside of our function, I will get nothing. Because data definition statements will actually not work inside of a function, or they will work with a limited effect. And this is wise because functions can be executed for each row of some big table. And it wouldn't be wise to have data definition statements executed so much times. Let's prove that even more. I will now try to create a function that will alter a name of a column for my sample table. So I will run this, and I will get that this is not allowed. So we can conclude that functions are for calculations. Their goal is to return some value. It is not their duty to change the state of a database, and that is why data definition statements will not work inside of custom functions, or they will work with a limited effect. I will now clear my screen. I will now conduct one more test. I will try to change environment variable inside of a custom function. So I will change my current schema, and then I will read variable current schema. I will run this, and then I will call this function inside of a select statement, and we will see that the result will be my new schema via C. But what will be the result if we read directly from the current schema variable? Well, again, we will get via C So that means that it is possible to change environment variables inside of a custom function. Next, I will show you that for function, it is also possible to return a table. So function doesn't need to return scalar. It also can return a table. We just have to define our return data type as a table. We have to provide column names and we have to provide data types of those columns. In this case, our function will return a content from my sample table. So I will run this, and then we can read from this function like this. So function can now be used as a subquery. So we will read from this subquery, and we will get the content of the sample table. Just the names of the columns will be changed. And tables that are returned by custom functions can be combined with normal tables. So here I will combine my sample table with the result of my custom function with the union all, and I will get a correct result. I will now clear my screen. We will now test, is it possible to use temporary tables inside of custom functions. I will first create one local temporary table. I will insert a value inside of this table, and then I will read from this table, and we can see a number 1 inside of this local temporary table. I will also create one global temporary table. Again, I will insert a value inside of this table, and then I will read from this table, and we have letter A inside of this global temporary table. And then I will create two functions. These functions will return tables, and the first function will read from local temporary table. So I will create this function, and similar to this, I will create another function which will use global temporary table, and at the end we can use these two functions. I will first try to read from this function that is using local temporary table, and this is successful, and then I will do the same with the global temporary table. So it is possible to use temporary table inside of a function. I will now clear my screen. If we want to use transaction statements instead of our function, this will not work, because transaction statements like start transaction or commit are transaction control statements, and they will not work inside of a function. So if I run this, this will fail, and this could be a big problem, because inside of one function we can have many statements, and we want all of those statements either to fail or all of them to succeed. A solution for this problem is to use word atomic. So I will show you this other example, and here after begin we have the word atomic, and atomic means undividable. So this word will transform this function into one big transaction, because our function is undividable. At the end, I want to remind ourselves on the fact that the function can be executed for each row of some table. So here, this function will be run for each number from this column. And this table here can have millions of rows, so we have to make sure that our function is efficient. We cannot make overly complex functions, because that will make our queries too slow.